Hello there. In this video, I'm going to go over the chemistry math diagnostic in some detail. Understand this, if you have not completed the diagnostic or you don't know what I'm talking about, you need to get this, you need to try it on your own first, and then come back to this, all right? So the purpose of this video is I'm going to go through it. I'm going to go through a little bit of detail about what I expect in each section. Choose to write some things down if you want to. If you're a note taker, I definitely recommend you write some of these things down. But also just kind of take a look. Maybe switch your pen. If you have a different color pen or pencil, go look over what you did. And if you made mistakes, correct them. Then you'll know, like, all right, I need to work on my algebra. Okay, I need to work on, or scientific notation. That's the purpose of this. Okay, so again, if you've not done this yet, do it first. Then come back and watch the video. And hey, come back to this whenever you want. If I'm going too fast, I'd like to remind you, thanks to the miracle of technology, you can pause the video and think, really think, about what am I doing in these examples. Do not just watch this through in order to get answers. Do watch this and think, like, all right, why did he do that? All right, do I understand why he did that? That's the idea here. So let's jump right into it. Scientific notation. This is something that's definitely going to show up in chemistry. Oftentimes in chemistry, we're dealing with very small amounts or very large amounts. An example of a very small amount is mass of gas in a container. Gas is not very heavy, so therefore its mass is going to be very small. On the other side of things, very large numbers. We deal with very large amounts of molecules and atoms. So scientific notation is something that you need to know. Now let me explain. Whenever you're looking at scientific notation, it's always going to be more or less the same format. It's always going to be some number with a decimal followed by some more numbers. It's always going to be only one digit before the decimal and then however many as needed right after. Okay, but it's always one number, one value, then the decimal, and then everything else. And also when you're looking at scientific notation, it's always going to be times 10 to the something. So that's how you know you're dealing with scientific notation. So A through D down there are all scientific notation. Now, scientific notation, as I mentioned, can be used to look at very large numbers or very small numbers. And you know that based on the value of the exponent. So if your exponent is a positive, here, I'm going to write that a little different. If you get a positive number as your exponent, that means you're dealing with a very large value. Okay, that means you're dealing with a very large value. That's what it means. Okay, if you have a negative exponent, that means you're dealing with a very small value. Okay, and so as we go through these examples, I think it'll make a little more sense. But again, if you're a note taker, I might be writing this stuff down. This little extra stuff I write, that's what I write down. So here we go. So let's look at A together. So A, it says 1.45 times 10 to the 8th. So right away, I know I'm dealing with a very large number. It's positive 8. That exponent is positive. So this is a large number. Now, the trick here is I want to move that decimal to show how large of a value it is. And so what I'm going to do is if it's a large number, I'm going to move the decimal to the right. So I'm going to go up here. This is when we move decimal to the right. Okay. To show that it's a large value. I mean, think about that. If we keep moving the decimal further and further and further to the right, isn't that making the number bigger, bigger, bigger? Yes. Now we look at B really quick. For B, that's a small number because it has times 10 to the negative 9. So in this one, I'm going to be moving the decimal to the left. And think about it. As we move that decimal further and further to the left, the number is getting smaller, smaller, smaller. Think about it. 0.1. 0.1, that's 1/10. But if I move the decimal over, it's 0.01. Now it's 100th. 0.001, that's 1,000. So as I move that decimal further and further over to the left, okay, I'm going to write it down, move decimal to the left. That's going to make the number smaller and smaller. All right, let's get to it. So, Mr. Nairn, for A, you said we're moving the decimal to the right, but how far are we going to move it? That's what the exponent tells us. So the fact that it's positive 8 means I'm going to move that decimal 1, 2, 3, 4, 5, 6, 7, 8 places, right? I'm moving the decimal that many places to the right. Maybe it'll help if I write it out. 1, 2, 3, 4, 5, 6, 7, 8. So see, we're moving that decimal from where it was to where it is now. Now, because we can't leave all this empty space here, right? We can't just leave all this empty space here. We have to put zeros there. So every one of those empty spaces, I'm just going to fill it in with a 0. And hey, that's it. That's all you do. So C, I'm going to rewrite the number. So this number is 145, and then how many zeros? 6 zeros. 1, 2, 3, 4, 5, 6. Add some commas, and that's how we know. See, this is a huge number. Positive exponent means a big number. So this is 145 million. And that's it. That's A. That's the non-notated form. Let's look at B now. So B, we already said this is a small number. We know that because it has a negative exponent. And so as I go in, I'm going to move the decimal to the left, right? Small value, you move the decimal to the left. But I'm going to move it 9 places. Because it's times 10 to the negative 9th, I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So the decimal is going to be over here somewhere. Here, I'm going to rewrite it. I think that'll be a little prettier. 1, 2, 3, 4, 5, 6, 7, 8, 9. And once again, we can't just leave the decimal sitting there. We're not going to leave all this empty space between the decimal and the numbers. And so, once again, for every empty space, that's when I'm going to go in and fill it in with zeros. So in reality then, this number is 0. Let's see, 1, 2, 3, 4, 5, 6, 7, 8 zeros. And then 6, 6, 7. Do you see why scientific notation can be really useful? It represents the same value, but instead of you accidentally writing the wrong number of zeros, and instead of having to write all that stuff or type all that stuff in the calculator, that's why we prefer scientific notation. But hey, it's the same value. So there we go. We've done a really large number and a really small number. Let's look at C together. This is another very large value. I know that because it's times 10 to the positive 9th, right? Okay. So we'll come down here and say, all right, 8.99 times 10 to the positive 9th. So once again, I'm moving the decimal to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9 places. All right. We're moving that decimal to the right here. I'm going to write down below to give myself a little more room. So see, I'm moving the decimal 9 places to the right, like that. There we go. And once again, fill in the empty space. 1, 2, 3, 4, 5, 6, 7 zeros in this case. 7 zeros in this case. And you might say, well, Mr. Noonan, why are we doing 7? You said it had a 9 as an exponent. Yeah, but keep in mind, we moved the decimal to the right 9 places, but we only needed 7 zeros, all right? And it's because we already had the 9 and 9 as we passed them. So rewriting this value, 899 with 1, 2, 3, 4, 5, 7 zeros, we see that this number is actually 8 trillion. Nope, that's wrong. 8,990,000,000. All right, so see, it's a really big number, and that's why it's a lot easier to write scientific notation. Scientific notation is just better. Let's look at D. This is another very large number. We know that because it's a positive 2 exponent. So once again, I'll move the decimal 1, 2, like so. And hey, I don't even really need to rewrite this one. It's 387, right? The decimal is right there. We don't write it, but we know the decimal is right there. Okay, and so that's the idea here. Let's look at this mathematically. Let's make sure you guys understand why we're doing this. Because technically, if you do it right in your calculator, you can type in scientific notation stuff. Like you could type in 3.87 times 10 to the second, enter, and it'll actually spit out 387. It'll give you 387. Let's look at why that is. Guys, what is 10 squared? Think about it. 10 times 10, right? 10 squared is just 10 times 10. That's just 100, right? So think about it. If you're doing 3.87 times 100, doesn't it make sense why you get positive 387? That should make sense. All right? That's how it works. All right, let's keep moving. Let's keep moving. Let's look over here at E. Okay, so for the next couple, sorry, let me box my answer. Box around 387. Okay, so let's look down here at E. Both E and F are what is known as engineering notation. Now, I know it's engineering because it has that E, that capital E. Now, I call this a little capital E. If you were to look at your calculator right now, especially the graphing calculators, it has 2 capital E's on your graphing calculator. One of them is a big capital E that you access using the alpha key. The other one, and I'll show you where it is on my calculator. Maybe you can see it. It's right above the numbers. You use the second button, and then you type right there and see it's a little lowercase e. In fact, it's written on your calculator as two little e's, two capital E's written next to one another. So make sure you're using the right one, otherwise it doesn't work. But the little capital E, actually all it means is this. A capital E just means times 10 to the something. That's all it means. So even though it's engineering notation, it's still just scientific notation. Typically, when I'm typing something in the calculator, I'll use an E rather than times 10 to the, because it's less buttons. That's all it is. So as we look at E right here, another way I could write this is like this. That's all. See, 1.25 e to the 3, same thing as 1.25 times 10 to the 3. And now, it's the same thing as the last problems we did. When it says times 10 to the third, that third means a positive 3, so it means it's a very large number, right? So if it's a very large number, that means I'm going to move the decimal to the right. 1, 2, 3. And then I have to add a 0, right? I have to add a 0. So this is 1,250. That's all. Let's look over here at F. F has a negative 5, right? It's E negative 5. This is going to be a very small value. So I'll move the decimal to the left. 1, 2, 3, 4, 5. So that means I'm adding 1, 2, 3, 4 decimals. Okay, so in reality, this one is 0. Let's see, 4 zeros. 1, 2, 3, 4. 4, 2, 3. And that's that. So you still do these the same way. All right, engineering is just another way of doing the same thing. All right, for numbers or letters G through J, it says rewrite in scientific notation. Okay, so now we're putting these in scientific notation. We got to kind of think backwards. So G, I hope that you guys are looking at that and you're saying, okay, that's a pretty small number. Okay, it's not big. I mean, I is a big number, H is a big number, but G is a very small number. And so as I look at this, excuse me, I could go ahead and say, I know I want something that looks like this, 4.62, right? Because you always do one number, in this case it's a 4, and then the decimal. Like, look back at our format, right? It's always going to be some number, decimal, and then everything else, all right? The same thing's true here. And then I know it's going to be times 10 to the negative something, because that's a very small number. The way I figure that out is, look, I want to move the decimal from where it is currently. See, look, I'm highlighting it for you, to right beside the 4, right? I'm trying to make it look 4.62. I'm trying to make 4.62. And so look, let's see how many places I have to move it. 1, 2, 3, 4, 5. I had to move it to the right 5 places because it's a small number. 10 to the negative 5. That's it. It's a negative because it's small. It's 4.62 because that's the format. That's how you do scientific notation. And it's negative 5 because we had to move the decimal place 5 times in order to put it where it needs to be. Let's look at H. H is a big number. I want the decimal to be right there, right? I want it to be 3.25 times 10 to the something. And I know I want it to be positive because, as I said, this is a very large number, right? It's a very large number. Now, where's the decimal? Mr. Aaron, there's no decimal. You can't do it. And remember, guys, even though we don't see it, technically the decimal's right there. Even though we can't see it, we know that there's a decimal right there. It's just that we don't write it, right? Why would we waste our time? So knowing that the decimal's there, let's look. We need to move the decimal 1, 2, 3, 4, 5 places. Except this time, it's a positive 5 in order to make this happen. It's positive because that's a big number. There we go. We did a big number. We also did a small number. Let's look at I. Letter I is another big number. So we have 60 billion, it looks like. Yeah. So decimal, where is it? It's right there. Okay. But I want to move it right next to the 6. I always want to have one integer. I always want to have one number next to the decimal. So I've got to go from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 6.0 times 10 to the positive 10. Times 10 to the positive 10. We move the decimal place 10 places. It's a very big number. That's why it's positive. Let's look at J. J, it's kind of a medium number. It's not really big or small. But because I'm having to move the decimal place over to the right one, because it's a small number, Yeah, it's going to be small. So in this case, I'm going to say, all right, so here we go. It's going to be 1.25 times 10 to the negative 1. It's kind of weird. I probably wouldn't waste my time with scientific notation for J, but hey, it's good practice. It's good practice what we're doing. Okay, that's scientific notation. It's something you need to learn how to do. All right, these are some practice. You can find lots of practice online with scientific notation. It's going to be something really useful to know. Something else that's useful for this class, of any math-based science class, is algebra. Students must be able to rearrange equations to isolate particular variables. So guys, that word isolate just means get it by itself. Get whatever letter it is we're looking for by itself. We want to isolate. So in other words, you want to be able to solve for specific things within a formula using algebra. Excuse me. All right. So for each of the following, we want to solve for the variable that's being asked for. So let's look at A together. A equals B over C, and the problem says we're looking for B. Nothing to it. All right, nothing to it. So I want to get B by itself. So in order to get B by itself, I need to get rid of C, right? C is over there on its side, and I want to get rid of that. I want to get B alone. So if B is being divided by C, what's the opposite of dividing? Multiplication. So if I multiply by C on the right side, doesn't that cancel C? Okay, but remember, whatever you do to one side of the equal sign, you have to do the other side. So I've also got to multiply C over on the left side as well. Let's rewrite this. So B is equal to C times A. Done. I isolated the variable. That's it. That's all I wanted you to be able to do, okay? We want to get something by itself. Let's look at B now. A equals B over C, okay? It's the same equation as before, but this time we're solving for C. Guys, for whatever reason, this right here is the hardest thing for students to do in this class. This is the hardest. When you have something in the denominator, that just confuses students. So understand this. There are a couple of ways we can do this problem. I'm going to show you the simplest way. So let's look at B. I want to get C by itself. And in fact, what I want to do first, because I don't like having that C in the denominator, I want to get it out of the denominator. So watch this. I'm going to multiply C out. Kind of like what I just did a moment ago. But the reason I'm doing that is now, look, I have C times A equals B. And you might say, well, Mr. Nairn, that doesn't work. You're trying to get C by itself. Why would you do that? Because I want to get rid of that fraction. You never want to solve for something that's in the bottom of a fraction. You want to get rid of the fraction first, because now it's going to be really easy. So in order to get C by itself, instead of multiplying by A, how about I just divide by A? Let's see what that does. Divide by A. That cancels it. Whatever you do to one side, you have to do the other side. There you go. And so we end up getting C is equal to B over A. And that's it. That's it. So understand, there is another way you can do it that I would argue is a little more difficult. Let's leave it alone for right now. Let's look at C together. C, we got some weird letters. So let me point out a couple of things. M is M. That's easy. That's like any other letter. Q is Q. They might as well be X and Y. But whenever you get something like CP, understand that's just one thing, okay? The P is a part of it, so keep it together. Delta T right here. We'll learn more about delta T later in the year. Not anytime soon, but later in the semester we're going to learn about delta T. But understand, this might as well say A equals B times C times D. That's really all it is, okay? So even though you start to see some weird stuff, look over there at D. We have P1, we have P2. That's still two separate things. It's just a way of labeling them, all right? So let's look at C together. Oops. Let's clean it up. Okay, so I want to get CP by itself. So how about this? Instead of multiplying out by M, why not just divide by M? Doesn't that cancel it? And whatever I do to one side, I got to move it to the other side. Right? So the M has been canceled, and I moved it over to the other side. And hey, while I'm at it, instead of multiplying by delta T, why not divide by delta T? Doesn't that cancel it? And then I'll move it over here, right? Whatever you do to one side, do the other side. There we go. I'm done. So what we end up getting then is CP is equal to Q over M times delta T. That's really all it is. So we have M times delta T in the denominator. They're underneath Q. But there you go. That's it. right? Not too bad, I hope. I hope that's not too bad. Let's look at D. D's a little more confusing. All right, so we got P1V1 over T1 equals P2V2 over T2. Okay, a lot of stuff going on. All right, we want to get V2 by itself here. I'm going to highlight it so you can see where we're shooting for. So we want to get V2 by itself. Okay, right now in the numerator, I have P1 times V2. Hopefully you guys understand that. It's P1 times V2. So think about it. If I want to get rid of P2, instead of multiplying, wouldn't I just divide, right? If I divide by P2, I can cancel it. Sorry, OneNote's got to think about it. I'm going to get a sip of tea. There it goes. So see, I can divide by P2. And again, I'm just going to put it over on the other side. So putting it in the denominator is the same thing as doing all of this. Just trust me. It simplifies out so that P2 is just in the denominator. I hope you guys know that from your math classes. But hey, let's clean it up. Let's look at what we got. All right, we're not done yet. Let's just clean it up a little bit. So I've got T1, P2. Yep, and this is equal to V2 over T2. So see, I'm close. The only thing that's left over there on V2's side is T2. So instead of dividing by T2, I want to multiply by T2. That goes over here. Whenever you multiply something over, it goes in the numerator, excuse me. Whenever you multiply something over, it goes on top of the fraction. Whenever you divide something over, it goes on the bottom of the fraction. So we end up getting this. V2 equals T2 P1, V1 over T1 P2. And if you're starting to say, Mr. Nairn, do we really have to do the 2's and the 1's and everything? Yeah, you definitely do, because otherwise you'll get them confused. Let's look at E. E is just a variation on the problem we just did a couple minutes ago, the ABC problem. It's the same thing. This is just using the density equation. So we're looking for V. Once again, I don't want to solve for a variable that's in the denominator of something. So step one, let's get that V out from underneath the denominator. We want to get it out. And I can do that by multiplying. So if I multiply by V, look at what it's going to give me. It's going to give me V times D equals M. And then basically same as before, if I divide out the D, just like that. There you go. And guys, I know I'm going kind of quick. What I recommend, and I know I said it earlier, is you can watch this later. You're going to have this on Google Classroom, okay? You can watch this later and slow down and pause and scratch your chin a little bit and be like, all right, why did he do that? Oh, yeah, because you got to do the same thing to both sides. Whatever you need to do. Go back and watch it again. All right, let's look at F. F, I'll just spoil for you. This is pretty advanced. Think of this almost like a bonus equation. So if you were looking at this and you're like, oh, I don't know, do you divide over the log? No, you don't. The good news is this is actually on the equation sheet, so this was just for fun. If we're trying to solve for h plus, the first thing I really want to do is multiply both sides by -1. I want to transfer that negative over so that I turn that negative in front of the log into a positive, right? So I want to make that into a positive log. So I end up getting negative pH is equal to log of concentration of H plus. You don't know what that means yet. That's okay. Understand the brackets. The square brackets mean something different than parentheses. I'm not saying log times H plus, right? That's not what I'm saying. I'm doing log of concentration. And so I don't know if you guys know this. Log means base 10. That's all it means. Whenever you're dealing on a logarithmic scale, it just means it's based on the number 10. And so honestly, all we have to do is if I do 10 to that and do 10 to that, it's kind of like this. If you have a number like a squared and you want to get rid of the square, you square root it, right? And then that cancels. Doing 10 to the log power cancels out the log. That's what it does. So let's see what we're left with now. I have concentration of H plus, that's what I was trying to isolate, get by itself, is equal to 10 to the negative pH. There you go. And again, guys, that one, don't worry about it so much. I was really just curious to see if anybody would get it, see who my math stars are. But you don't need to worry about it so much. Let's look at order of operations. Knowing how to calculate complex mathematical operations is important. It's critical you understand the order of operations as well as how to put this information into the calculator to determine a final answer. Okay, so we're just looking for a number value here. Let me remind you guys order of operations. I'm sure you know it. In fact, right now, you're probably saying out loud, PEMDAS, or please excuse my dear Aunt Sally. However you learned it, I don't really care. I just care that you know it. So there we go, PEMDAS. The P, hopefully you remember, stands for parentheses, right? The E stands for, that's not it, stands for exponent. Then we have multiply, and then we have divide with bad handwriting. There we go. And then we have add, and then we have subtract, right? So that's order of operations. You got to know how to do it. So let's take a look at A together. Now, hey, if you're really fancy with your parentheses, you can do, you can do all of these in one line on the calculator. You got to be careful. That takes some practice, and we'll work on that. I'm going to write it out. I'm going to kind of show the long way of doing it. But hey, if you get the right answer, if you get the same answer I did, you must know what you're doing. So let's look at A together. So I've got something times something times something. Okay. Well, I guess we're just multiplying. Everything's in parentheses, so I guess I just do everything. But if we look right here, we actually have a mathematical operation that's within the parentheses. So because we have 145 minus 80, that's within the parentheses, we actually need to do that first. So here we go. 145 minus 80 is 65. It's technically degrees Celsius if you're paying attention to that, which you should. And so, hey, we did it. Parentheses, check. That was the first thing. Now we're just multiplying. Really, we're just multiplying everything. I know they're in parentheses, but in reality, we're just doing 50 grams times 0.46 joules per gram degree Celsius times 65 degrees. We're just multiplying everything together. So I'm going to go ahead and do it. So in my calculator, I'm doing 50 times 0.46 times 65, and I get 1,495. That's what I get. Let's check our units real quick. This is something you're going to get practice with, don't worry. But as I look back at the units, I can see that I have grams and grams. Those cancel, excuse me. I have degrees Celsius, those cancel. The only thing that doesn't cancel is this capital J. So I'll put it right there. There you go. Put it right there. Let's look at B. All right, here we go. A lot of parentheses. But the thing is, guys, whenever you have parentheses that butt up against one another, right? What's the operation that it's really doing? It's just multiplication, right? So I could go in and put little dots there. And so really what I'm doing is I'm going to multiply everything in the top, then I'm going to multiply everything in the bottom. Notice, multiply comes before divide. If I look back at my order of operations, multiply comes first, and then we get divide. Let me check my recording really quick. Yeah, we're doing good. We're doing good. Okay, so here we go. I'm going to multiply everything in the top. So I'm doing 2.5 times 5 times 300. Oops, I did times 30. Got to be careful when you're typing in the calculator, guys. Okay, I get 3750. That sounds better. Now, 3750 what? I did atmospheres times liters times Kelvin. That's what I did. All right, let's do the denominator now. So I've got 275 times 2, excuse me, times 2, and I get 550. Okay, 550 what? Kelvin times liters. There you go. And so think about it. We did multiply. We've got to remember, though, these are being divided. These are still being divided together. And hey, that's the next thing. That's the next thing to do. Okay, so I'm going to do 3750 divided by 550, right? And I get 6.82. Is that what I got earlier? I may double check my calculator here in a second. But I'm getting 6.82. Let me double check really quick because I'm not sure I like that. Yeah, I guess that's right. Second guessing myself. All right. 6.82 what? Well, let's look. Let's look at what canceled out. Liters cancels liters. You got one on top, one on bottom. Kelvin cancels Kelvin, one on top, one on bottom. The only thing that's left is ATM. So this is going to be 6.82 ATM. There you go. Give it a second. It's got to think about it. I'm out of T. Oh, well. All right, here we go. Moving on to C. We getting close? Yeah, we're almost done. Let's look at C right here. Excuse me. All right, we're doing the same thing. We're going to multiply everything on top, then we're going to multiply everything on bottom. It's the same as before. Don't be tripped up by these units right here, okay? We're still going to do some unit canceling here in a second, but as far as the actual math and the numbers, we're not as concerned. So I'm going to multiply everything in the top, 2.5 times 5, and I get 12.5, and that's technically ATM times liters, right? Then I'm going to multiply everything in the bottom. So I'm going to do 0.0821. Be careful with your decimal. 0.0821 times 300. And I get 24. So I'm multiplying those. 24.63. I just call it 24.6. That's fine. And what about the units? Well, I've got a Kelvin right here. And I had another Kelvin down there. So the Kelvins cancel. And so really what I'm looking at here is I have liters times ATM, or AMT as I just wrote it. Let's try that again. ATM all over moles, which we'll learn what moles are later in the year. Understand, the point of this is not for you to know what all this stuff is yet. I want you to know the math behind it. Look, liters cancels. Atmospheres cancels. So we're left with moles. So when I do 12.5 divided by 24.6, my final answer is going to be let's call it 0.51 moles. There you go. So understand, the way I'm doing it right now is I'm doing it in little pieces, and then I'm checking my units, all right? And again, if you want to put it all in the calculator at one time, you can, but if you're not getting the numbers that I'm getting, you're doing something wrong, okay? You can be really creative with parentheses. So let's talk about that one I just did. If I were doing part C in the calculator, I'd put parentheses on top, and I'd do big parentheses on the bottom. So literally, what I would type in my calculator would look like this. Big parentheses, 2.5 times 5, right? Isn't that what we did? Close parentheses, divided by, parentheses again, 0.0821 times, 300. Close parentheses. So if you do that in your calculator and then you just hit enter, you should get the same thing. You should still get 0.51. The thing is, I'm telling the calculator, by using the parentheses the way I am right there, I'm telling the calculator, okay, calculator, do everything on top, then do everything in bottom, and then divide them. Because remember, guys, in order of operations, parentheses is first. So you can use parentheses to tell the calculator which way to do it. Calculators are really bad at order of operations. All right, as we look at D, tell you what, let's just do this one in the calculator. I'm going to just show you what I'd type in the calculator. Technically, yeah, you could do everything on top first and then divide by 5. But why not just tell the calculator to do it? So in my calculator, I would do 2.6 times 2.25, right? Close parentheses. Just got to think about it. There it goes. There's a little bit of a delay. So I wanted to do that first, and then I'll tell the calculator, okay, do that, and then divide by 5. Enter. Okay, so here, I'm going to do it really quick and tell you what I get. I'm typing it exactly the way that I just did. And I get 1.17. Okay? And again, you can go back and check if you want. Do the denominator, like on your own, and then divide by 5 on your own. But I get 1.17. Now, what are the units going to be? Well, look. Liters cancels liters. And then all we're left with is this capital M, which stands for molar. You don't need to worry about it yet, but that's what it stands for. So there we go, 1.17. Last one. Dun, dun, dun. pH equals negative log of 2 molar. Okay. I think that I guess a better way to do this, if I could edit myself, I would probably have done it this way and do square brackets. It's not a huge deal, but when you go on your calculator, it's going to turn it into round parentheses anyway. But a better way to write it would look like this. As soon as OneNote decide, there we go, to do it. But when you type it in your calculator, literally all I'm going to type in the calculator, because that's all you need to know how to do with this type. Okay, with type E, all you need to know how to do is type in the calculator. So in the calculator, I would just say negative log, parentheses, 2, enter, and that's it. Negative log 2. And you're going to get this number. There you go. It's thinking about it, but I got negative 0.301 and some change. So I'm just going to make it negative 0.30. That's good enough. So guys, understand this. If you're sitting in class right now and you're saying, gee, Mr. Nairn, I'm not sure if I'm going to do good in chemistry. Okay, I just went over all the math that you need to know for this entire semester. I just did it. That's it. That's all the math you need to know to do. Now, there's a couple little things I'll teach you, like how to convert things, but that's more sciencey and less mathy. This is all the math that you need to know how to do. So if you're watching this right now and you're saying, gee, Mr. Nairn, I am having a hard time with this, or I'm having a hard time with that. You need to be getting in touch with me, maybe to set up a time before or after school. Maybe we talk about it during Smart Period. We can go into more detail. A lot of these you can do more exercises on your own. But hey, there's my email if you want it. We're not going to do all this stuff right away. Hear me. A lot of this stuff that I just talked about is not going to happen right away, but it'll happen eventually throughout this year. Thank you very much for your time. Excuse me. I'll see you guys soon.